All right. But do we at least feel like we have some level of appreciation for quantum stuff now, like kind of what's coming, yada yada yada, and sort of how your field is going to be a major part of that. And there's upcoming technologies that are going to, similar to what we talked about earlier in the semester, you know, human beings, they aren't willing to come much more than like 1% in the direction of the technology. We don't want to get down to the hardware level. So even with the quantum stuff, what you saw last week is only just the start of trying to meet human beings where they are in order to do development in that world. Yet that's going to be a major part of the development you'll be doing in the future. And you see that, you know, probably it's at like 97% the way there. That's still not good enough for us, right? Still kind of an uncomfortable development environment. And and also it's a weird thing trying to wrap your mind around how do you leverage quantum mechanics to solve the kinds of problems it was built to solve. You know, we're going to have a similar thing in the second 8 weeks when we talk about something called recursion, which I think Wally maybe even mentioned with the quantum stuff. But recursion is when you have a function and that function calls itself from within itself. You know, the perfect example of recursion that we usually start with is the math function factorial. Factorial is 5 times 4. Factorial of 5 is 5 times 4 times 3 times 2 times 1. Well, the factorial of 5 is actually 5 times the factorial of 4, which is actually 4 times the factorial of 3, which is actually 3 times the factorial of 2, which is 2 times the factorial of 1, which is 1. So you can implement factorial in terms of itself, right? You kind of get that's recursion. And that's going to be not that all the other stuff has been trivial for you at this point, but that's going to be that next step where you're like, okay, well, how do I turn my head into thinking recursively, thinking like that? So hopefully you're starting to see a pattern with these different things where every time something new is introduced, the real challenge that you're having to jump through, the hoop you have to jump through, is this challenge of how do I train my mind to think that way, right? Because we've spent our entire lifetime thinking like humans talking to humans. And now we keep introducing these more and more uncomfortable situations where we're asking ourselves to approach problems in a way that doesn't come naturally to us, right? But again, this is like a sport with reps. You'll get there, I promise, but you're supposed to kind of still not be all that great at it. So keep that in mind, and I'm aware of that when we come to the exam. So let me spend a few minutes talking about the exam up front here. So first of all, obviously the exams are worth a huge part of your grade, right? So everybody's super comfortable about that, right? It's just great. Now, hopefully you've already seen in general, I grade homework pretty easily, right? You know, because I want you to put in the effort, but I don't want you to be punished for the effort that you put in when you didn't quite get it across the finish line. Then we come to class, you get to see the solution to it. Like I expect the assignment that you did for today, so many of you probably got it done, but you're kind of that idea of like learning how to convert something from decimal to binary, for example, is already this new skill. And then trying to tell a computer how to reproduce what you're doing, that's that little leap that we're trying to train ourselves to do. So it was probably a fairly uncomfortable assignment for some of you, I would guess. All right, so, you know, kind of keep in mind that there's a lot of reps that go in where you just have to keep throwing yourself into the ring, expecting to get knocked out until it finally starts coming around. So, you know, I'll remind you that my policy is if you do better on the final exam than you did in the midterm, I'll replace your midterm exam score with what you got on the final exam. So you can roll in, get a 3% on the midterm and do much better on the final, which is very common. And that 3% turns into a 92. Make some sense? You know, I'm not averaging them or anything. I'll replace the crappy score. All right. Now, having said that, the midterm does not have as much programming on it as the final will. So typically what ends up happening in a beginning programming class is you study for it, you understand the material. Really, you understand all the material pretty well when you see it. But you understand a chunk of the material on your own. But if you're having to solve a coding type solution on the clock, that becomes a tough thing, right? But I promise you over time, that's going to become easier. But it's not uncommon at all for you to lose a majority of your points on the programming questions and then do very well in the rest of the test. You're rolling with a 77 or something like that. And that gives you a foundation going into the rest of the course. And I do put questions, the programming questions on the exams. Keep in mind that you're on the clock, right? You know, they're not these highly, you know, you don't have to sit there and plan them out heavily. It's really just kind of asking you to show me that you can, you know, write the logic around a loop, do something so many times and, you know, some number of times and that kind of stuff. All right. So all my exams, no matter when you have them, my exams have 10 questions on them. There's no multiple choice, no short, true, false, no multiple choice. They're all kind of short answers. So it's either explain something to me or write a couple of lines of code that does something or write a function that does something or tell me what this code does. Sometimes I'll put a question where I show you some code and ask you to tell me what that's accomplishing. So those kinds of questions. So what I'm going to do is I'm going to flip through the slides real quick and just kind of tell you the ones, because I haven't written the exam yet. So I'm going to basically do the exact thing I do when I write the exam. I flip through the slides and I decide, oh, that's something that's extra important I want to test them on, versus this is trivia knowledge that needs to get thrown into the back burner somewhere because you might need it in the future, but it's not really something that's related to what you need to prove to me you've mastered for the class. Kind of make some sense? So rather than you having spending tons of time studying all these other things, let me try to focus you a little bit. So we'll spend a few minutes doing that. Then we'll look at the homework that was due today. That sound good? All right. Any questions before I start diving into that? All right. Probably should know what a programming language is. Really, that focus of the language is what we use to tell a computer what to do. Just as English is what we use to tell another human being what to do, or, you know, communicate with a human being. So understand that what the purpose of that programming language is. This will show up on there one way or another. You know, hopefully you're seeing I build my whole foundation of teaching computer programming around this idea of human beings solve problems one way, and all programming languages have facilities for those things. Okay, so human beings, we use our memory, we ask questions, repetition, and programming languages, all of them will have some way of us remembering stuff, some way to ask questions, and some way to repeat some stuff. All right, so understand that concept and that mapping between those. All right, there probably will not be questions on the exam specific to the CPU. Really, that was a connecting piece where we talked about what is, you know, how do our programming languages work when we take them from that high level that human beings can tolerate, let's say, and bring it down to this low level that computers speak. So we had to understand what that level is that computers speak, and that's what we talked about with the CPU. We referenced it like these magic tricks, but I'm not going to ask you stuff on that side because this course is about the programming side of things. But in order to understand the programming things, we had to understand what we're ultimately talking to this guy. But when you have the 325 course next semester, which is computer organization, that's when you'll focus in on the CPU stuff, okay? So there won't be questions specifically about the CPU. Same thing, kernel, that's the actual operating system. This isn't an operating system class. So again, this is just giving you a bunch of context, but I'm not going to test you over that. None of this history stuff with operating systems. The concept of compiling, that's fair game, where you take that high level language like C++ and you run it through something and ultimately get it to something that the computer understands. In here, we're not concerned with the stuff the computer understands. So for instance, if you remember, we looked at the hello world assembly in Linux. I'm not going to put anything like that on the exam where I ask you to walk through something like that. We saw it, we appreciated that ultimately that's something lower level that's closer to the computer's hardware than we're comfortable with. We know it exists, we know it leveraged the operating systems and stuff, so we see all the little tentacles coming out into the other areas of computer science. But in terms of the focus of this course being beginning programming, it's not really an important concept. But the idea that we have a tool that takes our high level code and converts it into the thing the program or the computer understands, that's important. And that's what a compiler does. Converts between a high level language and a low level language. There could be a question that takes that a little bit farther that talks about why does a compiler need to know about the architecture as well as the operating system? Why does it need to know about what processor you're running and what operating system you're running? So remember when we looked at that Linux hello world, it leveraged built-in things, those system calls inside of the operating system in order to get stuff onto the screen and things like that. I would probably have to be desperate for an extra question to get down at that level with a compiler, so I don't anticipate it, but I would say that would be fair game to take it just to that level. All right. This is fair game. 3 kinds of programming languages. We have our high-level languages that we like C++, Java, C#, yada, yada, yada. Then we have our low-level languages that we saw with that Hello World Linux. So just kind of know that exists. There's that intermediate language. And then we have those zeros and ones that the computer likes. All right, so that concept that those 3 things exist, yet we chill here at the high-level language stage. All right, none of the Apple story stuff. Very interesting, tells us how we got to where we are today, but I'm not testing you over that. Fair game, interpreted languages versus compiled languages. More fair game on a midterm than a final, because I can't quite give you as many programming stuff yet. So understand that we have a couple of different kinds of programming languages. We have compiled languages like C++, which we've messed with. And then we have interpreted languages, which you actually got a little bit of a taste of the last couple of weeks with Python, right? He was using Python in there. So that's an interpreted language. And this is no different than in real life. When you have an interpreter, you say things in one language. The interpreter in real time converts it into whatever the other language is. And then, so if I'm giving a speech in English, somebody else is converting it to German, then they're saying it in German, there's that little delay in the middle. Okay. Interpreted languages work through that delay because they're taking whatever you're saying in real time and converting it to something else. So they're considered to be a little slower. All right. But there's a zillion of them out there. Hence the reason for this quantum stuff. They selected a language like Python because they wrote a quantum interpreter in Python because computers are already really fast, and writing a compiled language is difficult. Computers are getting so fast that other than very specific applications, we don't actually need compiled languages too much anymore. Really, video games and operating systems. That's pretty much it. All right. So we have these interpreted languages, relatively slow. I'm not going to ask you to list examples of interpreted languages, more just that concept that we have a couple different kinds of languages, some that talk directly to the hardware through a compiler, and other ones that actually talk to another computer program, which then talks to the hardware. All right. I won't ask questions about this level of details with the front end, back end stuff, but there could be debating. I don't think I'll ask anything about RESTful APIs. Super important. But again, that building that foundation of what are the things that are floating out there that we're trending towards. I'm not sure I could really ask a good question at our level on a test for that. So how, HTTP protocol, server side, client side stuff, important, but not something I'm going to test you on. No RESTful API, no HTTP stuff. I could see something with possibly the data standard stuff, either XML or JSON. Just the idea that we have these things that are not programming languages. We have these data representation languages like JSON, like XML. JSON is really the one that's most related to your career now. It's kind of been the kid that won. It's not a programming language because these things don't have the ability to remember stuff or ask questions or have repetition, those requirements for all programming languages. But it is a data representation language. It allows us to organize stuff that we might use as input or output from our programming languages. All right. I wouldn't give you anything super detailed, but just knowing the existence of, these intermediate languages that are used for kind of structured communication. All right. Nothing about that. Conversion questions. Did we get to that? Kind of skipped that part. All right, so I won't ask any questions about speed conversion. I know we did one example, but we didn't. We'll write some code that does that and learn about it on the back end. So I won't ask. I won't give you a question that says, "Here's some data size. What's the equivalent in some other, a 2 terabyte hard drive is how many kilobit hard drive or something like that." I won't ask you to do that conversion yet, even though typically those are free points. Won't ask about that. Definitely something along these lines. I would just ignore the functional programming side of things right now, but the idea of a procedural language versus an object-oriented language. Remember, we had the example of the procedural versus object-oriented telephone, the pile of wires versus something that actually looks like a phone. All right, so understanding that concept that effectively object-oriented languages are upgrades to procedural languages that really just give us some organizational tools. Know about these number bases: binary, octal, decimal, hexadecimal. I could ask a question related to, like, for instance, why is binary popular, or why is hexadecimal popular in our computers. Remember, you wrote a paper on that type of thing. Okay, so now we're kind of getting into our conversion stuff that leads to our assignment for today. There will be at least one. Frankly, I'll probably put 2 of them on there, just given that we are, I need to ask some more non-programming questions. So at this point, I may ask a question for you going from octal to binary or hexadecimal to binary or vice versa using that shortcut we talked about. Let's see. Certainly something with the primitive types in C++. So these are related to memory. I might ask a question like, why do we have so many ways of storing signed whole numbers, bytes, shorts, ints, longs? That's that Y2K thing that memory used to be super expensive. C++ is an older language. It has facilities for allowing us as the programmers to make wise decisions how we're using our computer's memory. All right. But definitely know about these primitive types. You don't have to memorize these size ranges that each of them holds, but maybe have kind of that concept that bytes can hold a fewer range of numbers than an int can hold, something like that. The math for figuring it out actually is not very difficult, but you don't have to memorize exact numbers. I'm not going to say what is the smallest value that will fit in a byte. All right. Understand that chars are effectively a map between a number and our characters. So there's this lookup chart. C++ is called ASCII. In more modern languages, called Unicode. Probably won't ask you about that as a specific thing, but just that idea that chars are actually stored as numbers. And when we go in, you know, since we've marked it as a char, when the computer goes and displays it to us, it'll do that mapping for us and show us the character that we actually intended to store. Okay, that's because human beings, we like characters. Computers continue to like numbers. Okay, so we have this lookup chart. Floats and doubles, just like ints and longs, but these hold floating point numbers. And understand Booleans, trues, and falses. That's a thing. All right. And along those lines, be able to create Boolean expressions, you know, some number less than some other number, that kind of stuff. Because you'll have to use those for making if statements or loops, that kind of stuff. So really, you're starting to get into the applied stuff of how do we leverage the idea of a Boolean. I probably wouldn't ask you to write a program that says, you know, define 2 Booleans and print them to the screen, even though that would, maybe you'd like that. It might be a relatively easy thing to do, but, you know, the idea that a Boolean, that true false thing exists mostly for us to be able to ask questions and write loops that spin for some amount of time until we hit a condition. All right, this concept that all programs begin and end with main, I would say it's an important concept. It'll be on there in one form or another. You know, that when you run your program, it's going to start in line 1 of main and start going. All right. And if main says go to someplace else, like call some function, it will temporarily jump off the main wagon, right? Go over and run that function for a little bit till that function ends, then come back to main and continue on with the instructions. All right, so that concept of programs beginning and ending with main, very important because it keeps going past C and C++. You're going to see it in Java. You're going to see it in C#. You're going to see it in everything. And all of our modern languages are built off of, especially our compiled languages, are built off of C. All right, and then we kind of showed that. Here's a bunch of different versions of Hello World and in modern languages, and you see how they all have a lot in common. At the very least, that main method is there. I won't ask you to write any of this, or although it would be fair game. In fact, more than fair game. I will almost certainly ask you to write an error-free Hello World program. So something along these lines, based on what we've done in class, it would actually look like probably that. There's a function called endl that ends the line, but it's in a different library. So your version of Hello World should look something like that. So there is a very good chance that I will ask you to write an error-free Hello World program, in which case, since I said error-free, I'm looking for you to hit all the commas or all those semicolons and that kind of stuff. So it would be in your best interest to memorize that right there. Okay? And only this part's the actual code, that part. And the main rationale for that, I'm not a big advocate of memorizing stuff, because when you're in at work or whatever, you'll have references, right? Okay, but being able to write a Hello World program in all these different languages means that you can sit down, somebody says, write X, Y, and Z in language, whatever. If you can just immediately write a Hello World program in that and get it and run it, you now have a working development environment in which you can build whatever program you're actually building out of. So this means that you can get started with every language. Okay, so be able to write a Hello World program in C++. I won't ask you to do it in any of these other languages. So that's unrelated to this slide. This slide was really showing you that all programs begin and end with main. But I will ask you a question about write an error-free Hello World program. That will be one of the 9 questions, one of the 10 questions. So 10% of your exam will be to duplicate what I have highlighted there. See, nobody will get a 0 now. All right. Back to, that again, that constant reminder how human beings solve problems. I won't ask you anything about an IDE. We just appreciate that there's some special software out there that makes computer programmers' lives a little bit easier. Be able to define variables. If I say, create some number of variables and initialize them with some values, be able to do all that, understand the syntax of a type, variable name, and then a value. Be able to write some if statements where you're asking appropriate questions. Be able to read if statements, be able to write them. Relatively simple ones for the exam, but your syntax should be pretty close. It is a exam where I'm not expecting you, I don't want you to go in and write your code in online GDB and then test it. I want you to give me your best shot in the little answer box. So I'm not going to take off points for a missing semicolon there, here and there and stuff. I grade on competency. If you've shown me that you've mostly understood what's going on, you've given me code that if you were to run it, it'd give you your 2 or 3 errors, you'd fix them in 10 seconds and move on, you'll probably get full credit.
Question.
Go ahead.
When is the test?
Test is, did you read the email I sent out?
I didn't.
All right, so test, I spent a good amount of time writing that email. I know, it was great, wasn't it? Very heartfelt. Did you? Yeah. What did I say? I'd put it up. I put it up by Friday morning or something like that. I'll probably have it up earlier than that, to be honest. But I'm promising you the test will be up by Friday morning. Let's say by like 10 a.m. Friday morning or something like that. I'll probably put it up no later than Thursday night, though. You'll have to do it all in one sitting. All right. So I will probably extend the actual clock on it a little bit. So the intention is not for there to be a time crunch, right? So if we were in class, you'd have an hour and 15 minutes. I'll probably make it at least an hour and a half on the clock or something like that. But so when you go to take it, make sure you have that block of time sitting there so you can sit down and do the test. It's closed book. So I don't want you using any of your notes. I don't want you using the internet. I don't want you testing stuff on online GDB. You're only hurting yourself if you do that. I mean, at the end of the day, I don't actually care. You'll go and get your job. You'll get fired, and so it's just a thing. I won't give you homework over this weekend. So your homework between Friday morning and Tuesday will be to do this exam. That way we don't take up a class period to do it, since we've missed some classes here. All right, that makes some sense. Go ahead. Well, I have it set up with the security stuff in Blackboard. So when you go in and you click on the exam, it pops it open just as a normal web page. So you don't have to use the way I have it set up. You won't have to use a special browser or anything. But it'll know if you start doing some funny stuff. But you can always use your phone on the side, and I can't do anything about it. So but just don't. You're only hurting yourself. Anything else? Other questions about that? All right. So be able to write loops, maybe know the difference. This could be another kind of question for a midtermy thing when we haven't gotten too much experience with programming yet. You could probably throw the idea of a do while loop maybe out the window in terms of actually being expected to write code with it. But understand that we have one kind of loop that's a pre-check loop. We have 2 loops that are pre-check loops, while loops and for loops. They both will check that Boolean expression before the body of the loop executes at least once. Whereas that do while loop will execute the body of the loop one time at least before it might bail out. All right. So 3 different kinds of loops. Know what they kind of lend themselves towards. Effectively, what's on this slide. What's on this slide will probably be another question. Another 10%. Right? So now we're at a minimum score of 20% on the exam. While loops lend themselves to problems where you don't know how many times it's going to spin. For loops lend themselves to counting problems, even though you can use a while loop for that, but they lend themselves to that. And do while loops lend themselves to problems where something needs to happen at least once? Okay, so if you memorize this slide, you'll get full credit on that question. I probably wouldn't ask you to just regurgitate this slide. I'll probably ask some kind of question related to this slide that proves you have a comprehension of what's there. But you know, in general, if you have an understanding of this slide, there's another 10% of free points. Understand the assignment operator versus the equivalence operator, that single equal sign versus double equal sign. Double equal sign we use for making Boolean expressions is some number equivalent to some other number. That's the double equal sign. Single equal sign we use for assigning variable values. Int a equals 7 with a single equal sign. Okay. That probably isn't a question I'll ask you directly. It's something that just keep your head on a swivel when it comes to the programming questions. That might be the type thing I would take a point off for if you're not using the right combo of equal signs for either a Boolean expression or a variable assignment. So prove to me you understand the difference there. Also, the modulus operator. Understand that whole idea of long division, third grade math, where you divide something and there's a whole part and a remainder, and the modulus operator lets us get at that. And you practice with that for the assignment today, right? So and we'll look at that here in a few minutes. Definitely concept of variable scope, where we have access to a variable. So when you define a variable, it gets defined inside of whatever that the closest scope, and it's only accessible inside that scope. Be able to write Boolean expressions, be able to tell me what a Boolean expression is, any expression that boils down to a single value of true or false. As we get further and further into code, you'll start seeing that we can get some pretty complicated looking Boolean expressions. But ultimately, after you go through the whole war of boiling it down to an answer, it ends up being a single value of true or false. Still a Boolean expression, even though it looked more complicated. Be able to write for loops, understand the syntax for that. That's the modulus thing. So be able to work with this slide. Let me get into just some examples. Be able to write functions. There will be at least one, probably two questions on the exam where I say, write a function that does something. Pay close attention to whether I've asked you to write a function that does something and returns a value versus write a function that does something and maybe displays a value. There is something different about returning a value and displaying a value. So I will probably have two questions on there where that is being tested. In fact, one of the functions I'll probably have you return a value. The other function I'll probably have you display a value. I could also ask a question about what's the difference between a function that returns a value and a function that displays a value. Be able to tell me that. That is functions that have a return type of void versus functions that have a return type of something other than void, like int, char, or whatever. All right. So practice for these programming questions would be, things like the show countdown. That's kind of a similar size question that I might ask on an exam. Write a loop that goes through 10 times and does something relatively small inside the loop. That would be a exam level coding question at this point. All right, so this slide right here is what I just referenced about returning a value versus not returning a value. If you understand the contents of this slide, there's another 10 points. So we're at what, 30% now? It's free points. I'll tell you what, there's going to be people that miss these, even though I've sat in here and just said this will be on the exam. It's comical. All right. Understand the idea of the return keyword, that it doesn't just return a value. Return keyword also makes a function immediately end. Sometimes that's all you're going to use it for, is to kill a function. All right, so it's a two-step thing. It's not just to return a value, it also kills the function immediately. All right. This the make change question where you were using modulus, that's another similar size thing for a exam, although I probably wouldn't have you boil something down to so many individual things, 4 or 5, maybe it'd be like 2, but something that uses modulus to solve a problem, display all the numbers between 1 and 100 that are evenly divisible by 2 and 7 or something like that. Whatever, something along those lines. All right. Then there will be one conversion question on converting between decimal and some other base, where that base could be not binary, octal, decimal, or hexadecimal. I should be able to say, convert decimal to base 7. You should be able to do it, right? It's the same pattern. Convert decimal to base, 19. Same pattern. You just get a little deeper into the alphabet, past F. All right. So there'll probably be 2 conversion questions like these. One of them will be going fair game would be, you'll have 2 questions. One of them will be decimal to either binary, octal, hexadecimal. The other one might be another one of those, or to decimal to some other base, or it could be binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary. Those are the ones that have that shortcut. Where, octal, you have 3 binary bits equal each octet, 0 to 7. So go back and look at the videos to see those shortcuts. You can still do it by hand if you don't want to use the shortcut, but the shortcut makes it easy. So I will purposely pick binary to octal, that bidirectional thing, or binary to hexadecimal on purpose, with the understanding that if you know the shortcut, you can answer it pretty quickly. All right. All right, that takes us to our homework for today that we'll go and solve now. All right, any questions about the exam before I go ahead? Yeah, and really there's partial credit on everything. Yeah, there's always partial credit, but like I said, I grade mostly on competency. So if what you write to me shows me you largely understand the concept, you're probably going to get most of the points. If what you write does that little trick where you dance around everything but the answer, I've been doing this a little bit, probably not going to get many of the points. I'm looking for you to show me you understand the material, right? I'm not looking to nitpick a point or 2 here and there. So, if you pretty much have the right answer and you've shown me that you understand what I'm talking about, you just leave one little part off or something, I'll probably still give you all the points, as long as that part wasn't like this critical piece. Show me you understand it and you'll be good. Anything else? All right, so sound pretty fair? All right, but like I said, some of you are going to do poorly on the exam, because you're going to roll in, you're going to bomb the programming questions, right? You write me a little joke or something because you didn't even know where to start, and maybe I throw you a point just because I laughed. But don't let that get you down. As long as you can look yourself in the mirror after the exam and you said, look, I spent my time, I prepared for this the best I could. Some of these things haven't clicked yet. Just trust that they will eventually click. Okay, and that's where you get that second shot with the final to undo any embarrassment on the midterm. But if you look yourself in the mirror, you say, well, I've been half-assed into the homework assignments. I work with a group and somebody else is really doing most of it. And I kind of mess around on my phone the whole time. I'm not really learning stuff. Then you spent 10 minutes studying for the test or less. Then maybe you need to take a little bit of the blame and decide what do you need to go back and learn that you haven't already practiced, because you have 8 weeks of reps that need to be put in. Make sense? All right. Anything else on the exam? All right. So let's see if I can solve these questions, what I ask you to do. Okay. Oh, yeah. So I showed you, well, here's some examples of the conversion. So first of all, before you can solve any problems, you need to understand the solution that you're trying to turn into code, right? So for instance, for the function decimal to binary, which is one of the functions I asked you to write, this guy right here, decimal to binary, that's base 10 to base 2. We need to go and we need to look at an example of how that works, right? You start off with a decimal number. So given a decimal number, we want to return the binary value. Actually, I think in this case, I say display it because we're not collecting them yet. We'll start talking about strings. If not today, we'll start it on Thursday, and that's going to start opening up a lot of stuff. Although there will not be any stuff with strings. So the things I introduced, the new things I introduced on Thursday will not be represented on the exam. All right. So you don't have to worry about things that I haven't talked about yet. But anyways, so we have a input of 19 in this example. We want to convert it to binary. So what we do is we divide it by 2 over and over again, recording the remainder, and then whittling it down until we finally get to a 0. So when I look at this, I've solved it by hand. I say, okay, I want to do something a bunch of times. Probably a loop. Okay, so now we're in loop mindset. What do I want to do a bunch of times? Well, I want to take the current number. I want to divide it, in this case, by 2 and store that result. But before I do that, I want to output to the screen the remainder of taking this number when divided by 2. So print the remainder, then do the division. Do that over and over and over and over again until you're finally left with a number of 0. When you're left with a number of 0, that means that you are done doing that, replicating the repetition stuff. And presumably at this point, you've outputted all your stuff for this assignment. Now, I did point out in the assignment instructions that when we do this math, the actual correct answer is actually read from bottom up. So the correct answer here is 10011. Yet for this assignment, the expected output would be, since you're printing it out once per line, it would be 11001, because I haven't given you the tool yet to reverse stuff. Okay. So makes sense how to convert decimal to binary. And then we jump to the next thing and we see decimal to octal follows the identical pattern, except we're dividing by 8s. Decimal to decimal, which seems like a waste of time, but it still works. So it kind of proves to us that this process must be real. Does the same exact pattern, except we're dividing by 10. So 19 from decimal to decimal is 19. When dividing by 10, recording the remainder, and then continuing to work on until we hit a 0. All right, and then hexadecimal follows the identical pattern as well, except when you get a remainder that is 10 or larger, you have to replace it with the letter. So if you had a remainder of 10, when you read it, you'd actually say A. And a remainder of 11 is a B, so on and so forth. But I didn't have you write that for the assignment. All right, so we all understand the solution that we're trying to mimic in code. So as a human being, if I give you a problem like 27 decimal to binary, you could solve that, all right, using this pattern. So now we're trying to take that solution, the way we did it as a human, and turn it into some C++ code. All right, so let's go and write that dude. I'm just gonna gut all this. All right, like I said, I usually just do that quick little hello world thing, make sure my development thing is working before I start typing some other stuff. Everything looks copacetic. So let's go ahead and write our function. We'll write our first function, and then we're going to see that the other two are pretty much the identical function. So we're not going to return anything because we're going to be displaying some stuff to the screen. The first one is decimal to binary. And we're going to take a decimal number in as a parameter. Make sense? So that's my little prototype for it. That way main knows about it.
Some people might have different names.
Yeah. You can name this whatever you want. This could be whatever. The rest of it should all be the same. I mean, I don't necessarily care if you named your function something different, but that's the function name I told you about. All right, so we'll come down here. Let's go ahead and actually implement this guy. All right, so we're going to keep doing something until decimal to binary is a 0. Decimal number. While decimal number is not equal to 0, or you can say while it's greater than 0 if you want. So while it's greater than 0, we want to output something to the screen. What do we want to output? We want to output the remainder of the current value of decimal number when divided by 2. We want the remainder. So we'll go ahead and do a cout. Decimal number, mod 2. Put our little \n on here. All right, so we've displayed our remainder, right? And what are the possible outcomes when I get the remainder of something divided by 2? 1 or 0. What about when I divide it by 8? What are the possible outcomes for the remainder? 0 to 7. So dividing anything by a positive number n will give me a remainder of 0 to n minus 1. Okay? This pattern is identical here. So then after I've outputted what I need to output, I need to go ahead and adjust decimal number to be whatever it used to be divided by 2. And we're going to keep doing that over and over and over and over again until decimal number finally gets whittled down to a 0. All right. But now when it finally gets whittled down to a 0, have I outputted my final bit? Let's look at this here. So I start off, is 19 greater than 0? It is. So I'm going to output this 1, which is the remainder of 19 divided by 2. And then my decimal number becomes a 9. Is 9 greater than 0? Yes. I'll put the 1. 9 becomes 4. 4 greater than 0? Yes. I'll put the 0. 4 becomes 2. 2 greater than 0? Yes. I'll put the 0. 2 becomes 1. 1 greater than 0? Yes. Output the 1. 1 becomes 0. We don't get into the loop again, and we've outputted all of our bits, right? So what we have here is the answer. So I can go ahead and I can test this. We'll just call decimal to binary. We'll pass it our 19 as our example. We're expecting it to output 1, then 1, then 0, then 0, then 1. Big money, big money. Give her another college try here. Is the internet down? It's hard. All right, there's our 11001. All right, so we're cool with that answer. All right, so now we want to have a decimal to octal. And decimal to octal is basically going to be the same thing, right? We'll copy that guy. We'll name this decimal to octal. And instead of dividing by 2, we'll divide by 8. There's decimal to octal. And what was the what's one of our examples here? We'll just test our example. Oh, I did 19. So we should get a 3, then a 2. Decimal to octal, passing it a 19. There's my 3, then my 2. So it was the identical pattern. I just changed the 2s to 8s. Similarly, decimal to decimal. Seems like a giant waste of time, but whatever. It proves that the pattern works. All right, and this one we're dividing by 10. Make sense? And if we do decimal to decimal of 19, we should end up with a, well, a 9 and a 1, because it's going to print them in backwards, right? So there's my 9 and my 1. All right, does that accomplish the homework assignment? Let me save that. Then I'll share that. Put that on Slack. All right, so there's your solution to the homework for your reading pleasure. So as a in general, how did that assignment go? You appropriately difficult, like, but you felt solvable? Okay. So nobody spent more than 15 minutes on it? All right. But those are actually fun little examples, I think, because it makes you go and look at something. I mean, this is really, some of you have asked me, like, what can I practice to get better at this stuff? Coming up with little things like this, and then writing the code to mimic the solution. So fine, I mean, you know, converting decimal to some other base, it sounds like a complicated thing, but once you look at it, it's a pretty straightforward little math problem, right? And there's not a zillion things going on inside that loop. So you kind of, it's like, okay, well, I want to solve this problem this way. And then you go and say, okay, well, I've done it by hand. Now the practice I need to have is I need to turn this into code that does the same thing. So coming up with little utilities like that, converting from Fahrenheit to Celsius and, you know, those kinds of things, you know, yards to meters, blah, 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 you know, that gives you practice of turning the human solution into a computer solution, because that's the real skill. That's the difficult part that you are probably running into when you do your homework. You want to blame it on C++, but it's not C++. The syntax doesn't matter as long as you know what you're trying to say. Okay, it's trying to say the right things in the right order. So what we need to do now to take this to the next step is we want to write decimal to hex. So we're going to go to hexadecimal. Now we might imagine that, okay, well, this guy is probably going to follow the same pattern. Except instead of dividing by 10, we're going to divide by 16. Okay. And we might be tempted to just leave it at that. It's technically going to do all the right math. I'm going to go ahead and just comment out these so we're only seeing. Now I'm going to, well, here, we'll do 19 first. And we get 3-1. It's actually decimal to hex. Oh, I didn't change my numbers, did I? No, I did. 19 greater decimal number 19 divided by 16. That should be a 1. That's what I got. Oh, remainder 3. Yeah, we're good. That's the right answer. All right. So on the surface, it seems like, okay, this is working. But now I'm just going to arbitrarily pick a number, 2989, which is going to give me an 11, followed by a 10, followed by a what, a 13? Give me that in reverse. So 13, 10, 11. Those are bigger values. I didn't just do the math in my head. I picked that number for a very specific reason because I know what it converts to. All right. So 2989, it's giving me the 13, the 10, and the 11, which I know are the correct numbers. But now those numbers need to be mapped to the correct letters. All right. Because when we're doing conversions, things that are above base 10, so for instance, base 11 has a possible outcome for remainders of 0 to 10. It's that 10 that becomes the problem because we no longer have a single digit, octet, bit, whatever. We no longer have a single value representing it. Now we have a 2-digit value, 10, that it's unclear, is that a number 1 followed by a 0 or is that a 10? So we need to convert it into its equivalent letter. That makes some sense? All right, so if we have a 10 here, we're going to go ahead and we're going to say char number to letter. And we're going to take a decimal number here as a parameter. And we're going to go ahead and write this function. So what we want to do is, for example, if a 10 was passed in, this should give us an A. If an 11 was passed in, it should give us a B, so on and so forth. All right. Now, knowing what we know right now, we could just put a series of if statements in here, right? You might say, okay, well, if decimal number is equal to 10, return an A. Else if it's equal to an 11, return a B. Else if 12, return a C. 13, return a D. 14, Turn an E. 15. Now, as I'm writing this, we should be thinking that there probably is a better way, right? Okay. But hey, this will get the job done, right? If it's a 15, return an F. Now we know that any number divided by 16 will give me a value between 0 and 15. All right. But I only need to do a mapping for values that are 10 or greater. So now I have this function called number to letter that if I pass a value 10 or larger to up to 15, between 10 and 15, it'll give me the letter equivalent, right? So now I would go down to my decimal to hex, and rather than output this value directly, I'm going to go ahead and I'm going to create a variable called temp in this case, and I'm going to set it equal to decimal number mod 16. Then I'm going to ask the question, if temp is greater than or equal to 10, I want to see out number to letter on temp. So if my remainder ended up being at least 10 or larger, I want to output whatever number to letter converted it to. Otherwise, I can see out temp. Oh, missed several things in there. How about I scroll down there? All right. So added a little if statement in there. Get my remainder in a variable. So I'm going to remember my remainder. Then I'm going to ask a question. Is that remainder greater than or equal to 10? If it is, I need to convert it to the appropriate letter and output it. Otherwise, just go ahead and output it. It's already a number between 0 and 9. Make sense? All right. So now when I run this, I get BAD or DAB as it is. DAB. But the correct answer is BAD because we read it from bottom up. All right. That's the reason I picked that number. It's my hexadecimal example. All right, this makes sense? Now, let me ask you this. If I replaced all of the other three with this same logic, except changed the 16s to a 8s or 10s or 2s, whatever I was converting, would I still get correct answers? Yeah, I would just never get into this if statement, right? Because if I'm dividing something by 10, I'm never going to get a remainder greater than 9. So I'll never get into this if statement. Doesn't matter, doesn't mean I can't ask the question, right? But I'll never get in there. All right. So now we can say, you know what? It might be nice if we had, and the reason I asked that, we might say, it might be nice if we had a function maybe called decimal to base. So decimal to base. I'm going to steal my hex here. And actually, I need to update this a little bit because if I want to convert a decimal to a base, I not only need to know about the decimal number, I need to know about the number you want, the base you want to convert it to, right? So I need two inputs. What's your decimal value? And what base do you want me to turn it into? Make sense? So we'll come down here. This is decimal to base. We're going to take in the base as a parameter. So now, whenever I go and get the remainder, like in this case, I copied the code from decimal to hex. So rather than hard code a 16 in there, what can I put in instead? Base. Whatever value was passed into this function as the input for the user has called this function and they want me to convert it to base, whatever the variable base holds. I'm going to replace those things with base. So now this is written generically in terms of the input there, right? So now I can back up here and I can call decimal to base on this instead, except if I run it right now, it's going to yell at me. It's going to say, hey, decimal, there isn't a function named decimal to base that only takes one input. There is one that takes two inputs, but I haven't called it with two. I've only given it one guy. Okay, so it screams at me. Too few arguments. Haven't given me enough stuff. So I'm going to go ahead and I'm going to pass it my 16. So that's equivalent to what I had just done, right? Except instead of calling my hard-coded function of decimal to hex that only works for base 16, I'm calling my generic function decimal to base, which currently works for all bases between 1 and 16. And I should get my BAD. Or my DAD, as it was. All right, make some sense? All right, so now I can call the same thing again. And I can say, oh, I actually want that as a base 2 number. It's going to be a big base 2 number. Lots of zeros and ones. So there we go. There's our base 2 number. Okay. Base 3. Don't have a name. Probably trinary, I guess. So there's my base 3 version of that number. For base 4, does that have a quadrary? There's base 4, yada, yada, yada. Right? But if I said base 19, I better hope I don't get a remainder greater than, in this case, 15, right? Right now, we know this is going to work because we've seen what our remainders were. We know that the biggest they were going to be when I divided by 16 was what they were. So now dividing by 19, they're going to be smaller than that. So we're still safe. But if I put in some giant number here, this is just a blind guess of whether any of those things. So we did get one converted. Oh, but notice here we have see the space? We have another space. Why did we get a space there? It called number to letter, which is supposed to return a char, but it didn't find its answer in any of those if statements. So it just ended naturally, right? Never actually returning a value. Yet this guy down here was expecting it to give us a value. So the best thing it could do is just put nothing. In a more modern language like Java, it would have screamed at us and it would have said, you have advertised that this function right here, you've said that function returns a character, yet there are conditions inside here where it does not return anything. Java would not have compiled because of that. We have not written this function such that it will always return a char. Right now, it'll only return a char if I give it a 10, an 11, a 12, a 13, 14, or a 15. Otherwise, it never returns anything. We want to see the evidence of that. I can just return like, I don't know, question mark maybe. So we'll see those spaces will get filled in with those question marks. Which still isn't all that great, but it highlights the reason we got those question marks, or highlights the reason we have the spaces. All right, so as an example, if I have this giant number that I just took a guess at, and luckily we had some good remainders, we want to write a function, decimal to base, that supports all possible bases. Or what are all the possible bases? Up to base 36. Then we're out of alphabet, right? So we can go A to Z, but after base 36, we're out of alphabet. So what I'm going to show you here So we're just going to introduce the idea of this thing called a string. And I'm going to give you just enough of the stuff here to let you get your conversion the right way. Then we'll explain more about strings next class. So I can see out S here, and I get hello to the screen. We also have this thing called concatenation. So I can say S plus woot. And then I can see out S again. So I've updated S to be whatever it currently is, concatenated with woot. So now I'll get hello woot for that guy. But what if I want to say S is equal to S concatenated with a 5? And then see out S again. So I'm trying to tack a number onto the end of a string. Screams at me. It doesn't like that one of these sides is a non-string. So we have a function that's built into the string library, which I included right here. I brought something new into play here. So that string library has something called toString, which will take a number and turn it into its string representation. So in this case, that function will produce that. Double quote 5, double quote. That's what it does to it. Make sense? So now you'll see that this guy works again. So I'm going to save this. Grab the link. For your homework, update decimal to base in that guy to support all bases up to 36 and show the answers in the correct order. That is to say, use a string to build up your answer. I'm going to say in revert. Well, I'll just leave it. Build up your answer and then display it all at once at the end of your function. Example, decimal to base of 2989 should output BAD, not DAB. Should give it to me in the correct order and all at once. So you're going to be using these couple of new things that I've introduced here with strings. And as a hint, start off with the empty string. The empty string is a string that has no characters in it. So the empty string concatenated with woot, concatenated with 5 will give you woot 5. Okay. So that will allow you to build up your string as you go, and then ultimately output your string. Make sense what I'm asking you to do? All right, so that'll be for Thursday. I'll put the video up, yada, yada, yada.
Just going to some of the study sessions, I've been understanding